Assalamualaikum and good morning. We continue with chapter 3.6, Extremum of Functions, and we start with definition of relative extrema. So let f be a function defined on a region R containing x naught, y naught. Number 1, the function f has a relative minimum at x naught, y naught if fxy greater than or equal to fx naught, y naught. We represent definition number 1 as this graph. We have a curve like this. We have fxy. And then we have a point at the bottom of this fxy called as x naught, y naught. And we know that this point has zero slope. Therefore, x naught, y naught can be considered as a relative minimum. And then the second one, the function f has a relative maximum at x naught, y naught if fxy less than or equal to fx naught, y naught. For this one, we have a curve like this. And we have a point at the top of this function fxy, and that point we call as x naught, y naught. And of course, this point has slope 0. X naught, y naught is a relative maximum. Then we move to the next definition, critical points. Let f be defined on an open region R containing x naught, y naught. So the point x naught, y naught is a critical point of f if one of the following is true. The first one, fx x naught, y naught equal to 0 and fy x naught, y naught equal to 0. And the second one, we have fx x naught, y naught or fy x naught, y naught does not exist. But for this topic, I only focus on number 1. As usual, we have steps here, how to determine the critical points. So to show these steps, I will use example 2. So this is the question. So we start with step 1, compute fx and fy. Step 1, fx, partial derivative with respect to x. So in fxy, we have this x. So differentiate to x cubed, we have 6x squared. And then differentiate 3x squared, we have 6x. For fy, we have this y in fxy, and differentiate them, we get 3y squared minus 36y plus 81. And then we move to the step 2, let fx equal to 0 and fy equal to 0. Just take whatever in fx, then make it equal to 0. And this one equation 1, and then take the answer for fy equal to 0, and this is equation 2. So step 3, solve fx equal to 0 and fy equal to 0 simultaneously. We can see that in equation 1, we only have one variable x. So we have to solve this one first. So we factorize 6x squared plus 6x equal to 0. We get 6x, x plus 1. And then 6x equal to 0, and we have x plus 1 equal to 0. And then solve for both. We have x equal to 0 and x equal to minus 1. Do the same for the second equation, factorize. You can use your calculator rather than use manual calculation like this. So finally, you will get y equal to 9 and y equal to 3. Next step, step 4, determine the critical points. The critical points comes from the answer in step 3. So we have x equal to 0 and y equal to 9. So our first critical point is 0, 9. And then we have x equal to 0 and y equal to 3. Then 0, 3. Then we match x equal to minus 1 with y equal to 9. So we have minus 1, 9. Then x equal to minus 1 again with y equal to 3. So we have minus 1, 3. So obviously we have 4 critical points. And we finish answer this question.